today's the day the Raspberry Pi 400 arrives, and you can't park your van much closer than that, can you? Because it's a heavy box. Let's wait to see what happens when we unbox it. So the guy managed to find my door and deliver the parcel. So here it is, a Raspberry Pi 400, which I'm going to open somehow. Oops, look at that. Let's see what's inside here, using my reverse camera on the phone. Nice. Everything comes wrapped in brown paper, all the good things. There's the official power supply for €7, and there's the official Raspberry Pi in a box. I've got the DE version because I learned to type on a DE keyboard, German one. So let's open this up and see how it works. Well, it certainly comes in a nice looking box. Look at this. Very good. Only problem is how to open it with one hand. It wasn't designed for I won't say it. People with one hand. So, using the elbow to hold it down, you can open the box and oh, wow. This looks really nice. Wow, it's nice, quite heavy, and looks like just a keyboard. Wow, that feels like a really nice laptop quality keyboard. Wow, I'm impressed. More impressed than I thought it would be. And here's the back GPIO connection. Wow, micro SD card slot, micro HDMI, two of them, power USB 3, and USB 2, and a network socket. And it has built-in Wi-Fi and Bluetooth, of course, which I probably won't use, but never mind. Looks like it doesn't have too many screws to open it up. Reminds me of my first ever computer, which was a Sinclair ZX Spectrum back in the 1980s. Or was it late 70s? I don't remember. It was a lifetime ago. So there we are, the Raspberry Pi 400 microcomputer with 1.8 gigahertz CPU instead of the normal 1.6, and apparently has a big aluminium heatsink in it, which is what's making it so heavy, and probably has no fan, let's hope. So let's install some software on it, maybe the official operating system, or maybe Ubuntu. Let's see what I do. Well, there are no screws, so perhaps I won't open it immediately, but I've just noticed on the back there's a label, and quite surprisingly it says made in the UK. Oh, which province of China is that, I wonder? Amazing. This looks like a really nice product. Let's go plug it in, see what happens. There's the Raspberry Pi 400 plugged into a monitor and a mouse. But of course, before we can get it working, I have to install some software on a micro SD card. So I decided to blow the dust and cobwebs off my Windows computer because it's got the little Raspberry Pi app on it. So I started Windows 10, which I haven't used for a little while, and oh look, updates. No thanks. Just a moment. This is my favorite Windows scenario. Eventually you're allowed to use your computer. Close, all done. Right, thank you very much. Let's get on with what I wanted to do, which is to download, I think, Ubuntu, the new release for the Raspberry Pi, put it onto the micro SD card, and then go ahead and check the Raspberry Pi out. To do this, I'm going to use the Raspberry Pi Imager because it already finds the software straight away, which is here, and have a look, choose the OS, see what they have, what's on offer. Ubuntu, aha, 20.10 Raspberry Pi, oh, okay, 32-bit, 64-bit, desktop server, another server with long-term support. Well, there's quite a, wow, I haven't looked at this for a while. There's quite a lot of new software added. So let's have Ubuntu Desktop 20.10, 64-bit Raspberry Pi 4 models. Yep. So there we are. Next thing to do is to put in a SD card and then press write, and then we'll see we'll have a programmed card. Before writing to the card, I'm actually going to erase it using disk part. How do we spell disk part? And get a phone to focus at the same time. Disk part, like that, which pops up another window like that called disk part. Let's just do a quick list. Disk, I need to get a tripod. This would make everything so much easier. What do we got here? Okay, disk number 3 is 59 gigabytes. So it's 59 gigabytes free. That's interesting, but let's do it anyway. Select disk 3. Let's just this disk again, and there's an asterisk next to number 3 now, which means that one's selected, because when I wipe it using clear, I think, then I made sure I want to wipe the right disk. That was the wrong command. So, interesting. I haven't used this for so long that I don't remember what commands to use. If it's not clear, it must be something else. Hold on. Okay, so I went away and looked it up. The word I'm looking for is not clear at all, but it is in fact clean. And there's no command line history, so I have to type it again. Clean. And let's see what happens this time. Disk part succeeded in cleaning the disk. Let's just go back to list disk. Well, there is command line history. And yeah, still 59 gigabytes free. Hopefully now it's been cleaned. So there should be no partitions on that little micro SD card, nothing. So now I'm going to run the Raspberry Pi imager again. You notice that everything's the right way around this time. Choose operating system Ubuntu 20.10 Raspberry Pi 4/400. Wow, the 400 is listed. There's been a lot of progress here. I haven't looked at this for a while. Choose the SD card. I want that one, 63.9 gigabytes. Right. So there we go. Actually, before it can write, I think it's going to have to download the ISO for the Ubuntu, which is probably a few gigabytes and will take a few minutes. So I'm just going to get back to you when that's downloaded and finish writing. Well, look at this. Here's some action. I plugged in the power on the monitor, didn't turn on, or didn't press any on-off buttons yet, and already the Pi has started up, and it's looking for an SD card, which is not yet finished writing because it's in this Windows computer here, still being programmed with Ubuntu. So that's going to take a little while by the look of it. This started up as soon as it was powered on, which I wasn't expecting. Actually, I noticed on the keyboard there is a power switch, which is new to me with the Raspberry Pi, on the F10. So it's red, so perhaps I have to push a red button in combination with it. Let's try function F10. Maybe that will turn it off. Or maybe it won't. I'm pressing and holding. No, maybe it's Raspberry F10. No, okay. Maybe there are other ways of turning it off. I'll have to read the manual. As we always say in polite English, RTFM. Anyway, let's wait for the SD card to finish programming and then I can put it in and switch it on properly. So the writing the card is now finished. That took about 25 minutes. It was long enough for me to make a cup of tea, drink it, and then make another cup of tea. Anyway, 25 minutes. That's quite a long time. So where is the SD card? This is a Intel NUC teeny weeny computer that says it's okay to remove the card, so let's do it. Here it is. It's a lot of minutes to put data in such a tiny card, isn't it? This is switched off, this little Raspberry Pi. So let's see if I can get, with one hand, the micro SD card in the slot. And I don't know which way around it goes, but, oh, it has a click. Now the old Raspberry Pi, the original, doesn't go click with a spring. You just shove it in. So that's nice, another improvement. And I discovered by Googling it, which wasn't easy to find, how to turn it on. And we use function and then F10, pressing both keys simultaneously. This is designed for people with big hands. Oh, lights flashing. That means it's probably starting up. So let's have a look. Oh, that looks familiar. The start screen for a Raspberry Pi computer. Sorry about the reflections. So there it is. It's much smaller than a standard keyboard, and it's about the same size as the Apple Bluetooth metallic keyboard, which has batteries in it and no computer. This one has a computer in, the latest and greatest. It's probably released just a day or two ago at the most. And now we see starting up Ubuntu. It has to do some installing probably of itself, so it might take a while. I've got a mouse plugged in, so I'm raring to go and see what happens. Probably it'll take less time to set itself up and start running than it did to program or write that micro SD card, but let's see. So I'm going to fast forward. So it's getting somewhere. There's the familiar choose your language, and I think we're going to choose English, stick with that. Okay, it's not as snappy as some of my faster machines, but what do you expect from a tiny weeny computer? Let's choose keyboard layout, which in my case is German, which just means the Z and the Y are swapped around, I think. Yes, German. Okay, continue. And then it's going to ask me for a username and a password, just like any Ubuntu distribution. Oh, it's already got the location because I've already plugged in a network cable. So it's got the time zone as Berlin, which is close enough. Central European time, winter time. My name is always user, and we have to give the computer a name, which is going to be, I think we're going to call it Pi 400. So I know which one it is because I've got more than one computer in my network, and sometimes it's not easy to know which is which. Let's put a small I don't like those big eyes. Pi 400, pick a username user, the usual password, and then let's enter it again to compare. You didn't see that, did you? Required to log in, continue. This is very standard. Normally, of course, I like to use Linux Mint because it's, oh, I thought Halloween was over. Well, never mind. Yeah, because Linux Mint has so many things already configured, it makes it quicker and easier for me to use. But Ubuntu, sometimes I prefer to use that, especially for servers. And for this little machine, because it's got a ARM processor, there's only the Ubuntu available and no Mint distribution yet, which is fine. So I'm looking forward to using it. It's obviously going to take a little more time to configure itself and set itself up before we can do anything with it. So let's jump forward again in time. So let's jumped a bit further ahead in time. The usual pretty setup screens seem to be working, and it won't be long now before we finally have this system running and usable as a desktop computer. And now here we are with the Raspberry Pi 400 booted into the latest Ubuntu. Works nicely, it looks great. This is a 27-inch monitor, which is too big. I've decided I only need 24-inch monitors, but never mind, too late. So update, 62 megabytes to be downloaded, install now. Probably is going to ask me for password. It's not as snappy, of course, and fast as some faster computers, but it appears to be at least usable, which is the main thing. That's interesting. Let's just click on the updater icon because it's obviously doing some updating, not showing me what it's doing. And it didn't ask me for the root password. That's interesting. It just goes ahead and does it. There we are. So we're downloading some updates, which will no doubt take some time to install. Oh, that's nice. Okay. New purple buttons showing when they're 100% downloaded. So far, things are looking good. So it's installing the updates. Let's just click down here, see what software is installed out of the box with this version of Ubuntu. The usual, it looks very familiar. Let's have a look at disk usage. See what's going on there. Oh, I did click the button. Oh, there we are. So 56.8 gigabytes available from the 62.5 on the 64 gigabyte micro SD card. So the OS has not used up a whole lot of space, maybe 6 gigabytes or so, like 10% of the card. Still installing updates. Maybe that was why it was a bit slow to open the update window. What else we got here? The usual things. Yeah, looks very standard, and I'm sure it's going to be a nice little system to use. Of course, I could have put this on a laptop. I've got laptops. They've got batteries in them and screens on them. They're very nice and portable, but somehow I just like the Raspberry Pi, and I like the retro feel of the original personal computers that came out before the IBM PC was invented. And all those kits we used to put together back in the 80s. So it's kind of nice, and it's got the cables that you can plug in easily to the back, and of course the GPIO port for electronics projects to plug in. So I'm looking forward to having some fun with this. At the same time, you can probably surf the internet with it. Whilst the updates are installing, I decided to change a few settings to my favorites, like dark mode. Privacy is interesting because I like to turn off this connectivity checking, which keeps pinging Google usually once a second. So I turn that off to save all the embarrassment of all those multiple pings. And what else do I like to change? Default applications I already did change to some keyboard shortcuts I like to use. Let's have a look at the About section. And what does it say? Ubuntu Pi 400 memory, 3.7 gigabytes usable memory. Processor. Oh, we don't have a processor. Never mind. Graphics. There's the built-in graphic adapter. Disk capacity unknown. It's a micro SD card, I suppose, not a SATA drive. And operating system 64-bit and so on. Interesting. The processor hasn't got listed in here, but I'm sure there is one because otherwise you wouldn't be seeing all of this. So that's a nice computer. I like it so far. I've decided to install some favorite software on here, like Hard Info. You can just type it straight in. You don't have to click in the window. This one I like to use for testing hardware. It's actually installing already. And of course I like to use the system monitor to look at the CPU load and free memory. You can see there's the 4 cores and a little bit of network traffic. Memory used 1.5 gigabytes out of 3.27 available, and no swap used yet. So that's Hard Info being installed. I'll also install S-2E TUI. That's a nice program for loading the CPUs. It's a terminal-based program. And then what I will probably end up doing is plugging in my power meter to measure how much power this takes from the 240 volt supply. That always interests me, looking at power consumption of computers. One of my laptops takes 6 watts when it's doing nothing, and it's a Core i7 processor. I have other computers that take 100 watts or 120 watts when they're doing nothing. That's before you even load the processor, which is a lot slower than my laptop. Just shows how much progress is made in technology. So we'll have a look at that in a little while. Maybe I can run this. Not yet. Okay. I think this version of Ubuntu has some packages differently installed to what I have on my other machines. I wanted to run NeoFetch because it's nice just to see what we've got, and doesn't work. Okay, so I just followed the standard instructions to add the repository where NeoFetch is stored, and then I wanted to go ahead and install it. I've already done this once, but I can do it again. And it didn't want to let me because it's not secure. Gosh, this is taking a long time, isn't it? Anyway, maybe I'll just scroll back when I went to install NeoFetch last time, or we can just do it again. Yeah, update and install NeoFetch. So let's do that. And it says, there we are, does not have a release file for Groovy. Updating from such a repository can't be done securely, and it is therefore disabled by default. Interesting. I haven't come across that before with other Linux distributions or even Ubuntu on other machines, but I'm sure there's a way around that. So to measure power, I want to measure it with no load on the CPU and then with load on the CPU. So I'm installing S-TUI, the command line based program. It's just finished installing using that command, and let's run it, see what happens. Oh, seems to work. Look at that. What have we got at the moment? We've got a CPU temperature of 36 degrees whilst it's doing relatively nothing. I just booted it a few minutes ago, so maybe it's checking for updates. So there's 36 degrees, 35 CPU temperature, current clock frequency of 700 megahertz because it's not loaded yet, and the loading is quite low, up to about 3% that was, because it's not doing very much. So there we have a nicer graphical display. 37 degrees is here. Isn't that the human standard body temperature for healthy people? I think it might be. core frequency is pulsing a little as it's doing something, and the utilization is practically nothing, those little green bars at the bottom there. So this is in monitor mode, and what I've done is I've plugged in the power supply to my trusty power meter. It's on the floor, it's dark down there, so using my trusty torch, or for those watching in the USA, flashlight, we can see that this computer is consuming 2.8 watts, 2.9, 2.8, something like that, whilst it's doing relatively nothing, as you saw on the screen. And what I'm going to do is I'm going to stress it by moving the cursor to stress and pressing the space bar. So now the CPU is stressed and all 4 cores should be fully loaded. Takes a little while for the graph to update, but you see now there's 100% CPU load on each of the cores. That's the average CPU load, which is 100%. Frequency has gone up to the maximum clock frequency of 1800 megahertz, which is what we expected, 1.8 gigahertz, and the temperature is beginning to rise from 37. It's now up to probably 46. Yes, 46 degrees or so. So that's full CPU load. I'm going to leave it like that for a few minutes and see if we can detect any heat coming out of this Raspberry Pi 400. And whilst it's running at 100% CPU load, I'm going to turn on my flashlight again, go under the table, which is actually a wallpaper pasting table, but never mind, and look at the power, and it's 6.1 watts. So that's the full CPU load. That's what my lowest power laptop takes when it's doing nothing. With no load is 6 watts. This is fully loaded 6. So that's quite an economical, environment-friendly computer to leave running all the time. I do have another Raspberry Pi that is a little web server for internal use. Sometimes it's a Pi hole, and with power consumption as low as that, you can leave it turned on. I remember the days when just the lamp on a piece of equipment that lit up to tell you that it was switched on would consume at least 6 watts before the machine had even started. So that's progress. So there we are, 100% CPU load. Let's see if this thing is warming up. Oh yeah, I can detect a little bit of warmth. That's interesting. Oh, now I've got an application for my thermal camera. Let's use the thermal camera on this phone, which I bought because sometimes... Oh, wrong pin. Try again. It was a bit too fast. Wait a minute. I'm having a problem here. Putting the pin number in my phone. One-handed. Without showing you what it is. Okay, there we are. This mobile phone has a FLIR camera. Thermal camera. So let's start that up. And then I can look at the Raspberry Pi 400 and see where the heat's coming out. And I can compare it to a normal keyboard. Where's my normal keyboard? There's a normal keyboard, which is actually not plugged in, it's doing nothing. And so there's no heat coming out of it. And here is another normal keyboard. It's got some temperature because of the room temperature in here. There we are, 20.5 degrees C. It's an aluminium keyboard, so it's not that warm. It just looks warm on the camera because it's relative temperature that's being measured. Here, what have we got? 26 degrees on the keyboard itself. At the back there's a bit more heat coming out, 27. It's a very sensitive camera. Only very small changes in temperature cause big changes in color. Well, there was 29, almost 30 degrees. So that's the front of the Raspberry Pi. If I feel it, I can barely feel any warmth, but on the backs, I could. I almost said a rude word there. I managed to stop myself. On the reverse side, there I could feel some warmth coming out. So let's have a look at that with the thermal camera. See what's coming out of there. It's not easy using 2 mobile phones to film something. Come on, focus. 32. So yeah, I was right. I could feel a little bit of warmth. 32, 33 degrees. That's probably where the CPU is located. And you can see the heat sink. It's probably here, or maybe it's actually a bigger heat sink. Maybe it actually includes these 2 stripes. Interesting. I haven't taken it apart. I did look at some photos where somebody else did a teardown of their Raspberry Pi 400. So I know that there's a big aluminium plate in there as a heat sink. As you can see, we've got now 33 degrees maybe on the reverse side of this computer, which is, you can feel it, but it's certainly not what I would call hot. Let's have a look at the display here on this stressing program. Temperature of the actual, on the die, the chip itself is 50 degrees, which is okay. I have others that run at 70 degrees and seem to be happy. And they have big fans to keep them cool as well. So this is looking quite healthy in terms of power consumption and temperature, heating effect produced in the computer. There you can see the heat. And there you can see the screen. Some heat at the bottom of my screen as well. And there's the Apple keyboard, which is cool. There's my cup of tea. Yes, that's also quite warm. About the same temperature. Look at that, it's cooled down to 27 or so degrees. So that's it for now.